Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring how to solve a quadratic inequality in one variable. Before we do, let's look at an example which shows us the difference between solving a quadratic equation and a quadratic inequality. So in example 1, it says the graph of y equals x squared minus 4 is shown. So here is the function y equals x squared minus 4, and we're going to use this graph to help us answer the questions in this problem. So in part A, it says what two values of x would solve the equation x squared minus 4 equals 0, plot them on the graph. So if I were to solve this equation algebraically, I would have x squared minus 4 is equal to 0, add 4 to both sides, and then take the square root of both sides. So x would equal plus or minus 2. So our solutions to the equation x squared minus 4 equals 0 is x equals positive 2 and x equals negative 2. Now, if we were to plot those solutions, I want you to notice that both of those solutions fall on the x-axis, because those are our zeros of our function. They're the values of x that make the equation equal to 0. In part B, though, we want to know what values of x would solve the inequality x squared minus 4 is greater than or equal to 0. So looking at your function, we want to know, when will this U shape, when will it be greater than or above the 0? So it's pretty clear to see that on this side we're above 0, but notice we also have another place where we're above 0 on the left side. Now they want us to express the intervals of x that would make this equation true. So on the left side, this branch goes off to negative infinity down to negative 2. This branch starts at positive 2 and goes to positive infinity. So I'm going to express that in interval notation by saying parenthesis, negative infinity, comma, negative 2. I will use a bracket since we used a filled-in circle. Or we have positive 2. The other branch starts at positive 2 and it goes to positive infinity. So that would be the solution to the inequality as opposed to the equation. It's a range of numbers, an interval of numbers. Okay. Now, to express this solution on a number line, let me draw a number line here. Let's just say negative 2 is right here, positive 2 is right here. We would need to first determine whether I should use an open circle or a filled-in circle. And hopefully you remember from previous courses that because negative 2 and positive 2 are included in the solution set, we would use filled-in circles. Now, I'll do the one on the right first. We want to go from 2 to positive infinity. So that would mean my branch I draw would go off to the right like this. And our other side, let's see, the side over here goes from negative infinity to negative 2. So that would be like this. So there's the number line representation. Okay. Okay. Now, we can also use a table of a function to help us solve a quadratic inequality. So the table below represents some values for the function y equals x squared plus 2x minus 3. So this table shows some ordered pairs on this parabola. It doesn't show all of the ordered pairs on this parabola. It shows us a selection of ordered pairs. Of course, we know this parabola would go on forever. Okay. In question A, they want to know what two values of x would solve the equation x squared plus 2x minus 3 equals 0. Well, if we solve this by factoring, we would have to use an x and an x to get x squared. We'd have to use a 1 times 3 to get 3. And then we want to have a positive 2 in the middle. That means our 3 should be positive and our 1 should be negative. So that leaves me with solutions x equals 1 and x equals negative 3. Those are the two numbers that make the inequality equal to 0. Now, what I want you to do is highlight those in the table. So x equals negative 3 is right here, and x equals 1 right here. Now, what I want you to kind of notice is what is the function value there. And I want you to notice that both of these are equal. Whoops. Both of these values of x make the function equal to 0. So when x is negative 3, the function is equal to 0. And when x equals positive 1, the function is equal to 0. In part B, they want us to represent the intervals of x for which x squared minus 2x minus 3 is less than or equal to 0. So if you'll look at the table, let's look at our function values here. We have 12. Our first function value is 12. That's greater than or equal to 0. Let me get my pen here. This one was greater than or equal to 0. 5 was greater than or equal to 0. 0 equals 0. Negative 3, that's less than or equal to 0. Negative 4, less than or equal to 0. Negative 3, that's less than or equal to 0. Positive 5, that's greater than or equal to 0. 2, that's greater than or equal to 0. So if I want to represent the intervals for x, for which x squared minus 2x minus 3 is less than or equal to 0, then I'm only going to be able to use the intervals that fall in that area. So if I want to represent it on a number line, let me draw my number line. I would put my zeros of my function on the number line first, negative 3, positive 1. Then I would decide if the circle should be open or closed. In this one, it is less than or equal to. So because equal to, I will fill them in. And then I want to shade in the intervals. Negative 3, negative 2, negative 1, 0, and 1. So all the solutions fall in between negative 3 and positive 1 right here. Those are the intervals of x for which the function is less than or equal to 0. Now, in part C, they want us to express the intervals of x which would solve the equation x squared minus 2x minus 3 is greater than or equal to 0. So it's greater than or equal to 0 when x is less than or equal to negative 3, or x is greater than or equal to 1. That's when the equation would be greater than or equal to 0. So let me highlight those in a different color here. So I'm just going to highlight the greater than or equal to zeros so you can see that. X must be greater than or equal to 1, or x must be less than or equal to negative 3. Let me box that in quick. There's our solution to greater than or equal to 0. Would look like that written in inequality notation. Now, let's talk about solving quadratic inequalities algebraically without a graph of the function or without a table of the function. So here's your steps. The first thing you want to do is move all your terms to the left side of the equation. And you want the right side to be 0. Determine the values of x that would make the corresponding equation equal to 0. Then use the zeros to create a number line divided into 3 regions. Step 4, you're going to test a number that's between the zeros. If it's a true, your solution is the set of x values between the two zeros. If it's false, your solution will be in region 1 and 3. Then express your answer using inequality or interval notation. Now, let's look at an example of these steps and it'll make a lot more sense. So in example 3, it says solve each quadratic inequality. Express your answer in both interval and inequality notation. So step 1, move all the terms to the left side. So in this problem, step 1 is already done for you. Step 2, determine the values of x that would make the equation equal to 0. So I want to set this inequality equal to 0 and then solve it. So I'm just going to use factoring. You can use quadratic formula, but I think factoring is usually easier or quicker on these. So to get x squared, I would have to use x and x. For 36, I'm going to use 9 and 4. To get the negative 5 in the middle, I would have to make the 9 negative and the 4 positive. So now I know my zeros of my function are x equals 9 and x equals negative 4. Okay. Step 3. Use the zeros to create a number line. So let's do that. Here's my number line. I want my first 0 at negative 4. My second 0 is at positive 9. Okay. Now decide whether your circle should be filled in or solid, filled in or open. In this case, there is an equal symbol, so I'm going to make sure they are filled in. Okay. Now, what I want you to notice here is that we've created 3 regions. We have everything to the left of negative 4. We have everything in between negative 4 and positive 9. And we have everything above 9, greater than 9. So we have 3 regions, region 1, 2, and 3. Okay. Now in step 4, it says to test a number that's between the zeros. Now, what I like to do to make my arithmetic easier is I like to test 0. Whoops. I like to test the number 0 because it is definitely, in this case, it's between the 2 zeros, negative 4 and positive 9. So the reason I like to use 0 as my test point is because the arithmetic is much easier. So if I'm plugging in 0 to the original equation, okay, so we're still on step 4, test a number between the zeros. Okay, so I'm going to put 0 squared minus 5 times 0 minus 36 is less than or equal to 0. We want to know if that's true or not. So 0 squared is 0. Negative 5 times 0 is 0. So what we end up with is negative 36 is less than or equal to 0. True or false? Well, a negative is always less than 0. So this is true. Now, here's what that means. You now know where your solutions are. If your number is true, that means your solutions are going to fall in region 2, in between. So it asks us to write our answer in interval and inequality notation. So in interval notation, our solution would be negative 4 to 9 with brackets. Or inequality notation would look like this. X is between negative 4 and positive 9. So those are both 2 different ways of writing the same solution. All right. Problem B. We have 5x squared plus 28x minus 12 is greater than 0. Now notice this time it's not greater than or equal to. So we'll talk about how that changes. But step 1, move all terms to the left side. That's already done for us. Step 2, determine the values of x that would make the corresponding equation equal to 0. Now, this one's a little harder to solve just because the numbers are a little bigger. Now, I'm going to assume you already understand factoring, so I'm not going to take a lot of time to explain the factoring here, but I'm going to use 5x and x to get 5x squared. For the negative 12, I'm going to use 6 and 2. I'll put the 2 here, the 6 here. Now, I want a positive 28 in the middle. That means that needs to be positive and that needs to be negative. So now I know my solutions are positive 2 over 5, and negative 6. So those are my zeros of my function. So I'm going to make my number line again. Draw my little arrows. So I have a negative 6 and a positive 2 over 5. Now I have to decide, should my circles be open or filled in? In this case, they should both be open. So I'm going to put my zeros on there. Now, what I want you to notice is we've created 3 regions. Everything smaller than negative 6, everything between negative 6 and 2/5, and everything that's bigger than 2/5. All right? So, again, step 4, test a number between the zeros. So again, I'm going to test x equals 0. Okay, so 5 times 0 squared plus 28 times 0 minus 12 is greater than 0. So 5 times 0 squared is 0, 28 times 0 is 0. So what I end up, negative 12, is negative 12 greater than 0? No, negative 12 is smaller than 0. So this is false. So if your answer is false, that means your solutions are in region 1 and region 3. All right. So to write this in inequality notation, which I'm going to need a little room here, inequality notation would be negative infinity to negative 6 using parentheses, or 2/5 to positive infinity. So there's my interval notation. For my inequality notation, I would say x is less than negative 6, or x is greater than 2/5. So there are 2 different ways you might see the answer expressed on a test. Okay. All right, problem C. 2x squared minus 4x minus 8 is less than or equal to 10x minus 8. So step 1, we want to get everything on the left side. So I'm going to have to start out by subtracting 10x here and 10x here, and adding 8 here and adding 8 here. So that would give me 2x squared. Negative 4x minus 10x would give me negative 14x. Negative 8 plus 8 is 0, so that's less than or equal to 0. Now, what I want you to notice on this one is there's only 2 terms. So that means our only solution choice is to factor out the greatest common factor, which is 2x. So 2x squared divided by 2x leaves me x. Negative 14x divided by 2x leaves me negative 7. So now I know my solutions are x equals 0 and x equals 7. So I'm going to make a number line. So I have 0 and 7. And I want to decide, should they be open or filled in? So because it's less than or equal to, I will use filled in circles at 0 and 7. Now, on our test here, we're not going to be able to use 0 this time because I need a number between 0 and 7. So I'm going to make it as small as possible. I'm going to test x equals 1. X equals 1. Okay, so 2 times 1 squared minus 14 times 1. Is that less than or equal to 0? So this would be 2 minus 14 less than or equal to 0. So negative 12 less than or equal to 0. That is true. So if it's true, that means your solution set falls in between the 2 zeros. So to write that in interval notation, it would be 0 to 7. Inequality notation would look like this. 2 different ways of writing your solution. All right. Problem D. X squared plus 14x minus 6 is greater than 14x plus 19. Pause the video and try this problem on your own. All right, welcome back. Hopefully as your first step, you subtracted 14x here and here, and subtracted 19 here and here, which would give you x squared minus 25 is greater than 0. And then if you solve that by factoring, you would get x plus 5, x minus 5. So your two zeros are at negative 5 and positive 5. All right, and then hopefully you made your number line. So we have negative 5, positive 5. I would want to use open circles. And then notice we have region 1, region 2, region 3. So I'm going to test a number that's in between negative 5 and 5. So I'm going to test 0. So 0 squared minus 25 is greater than 0. So negative 25, is that greater than 0? Well, that's false. So whenever you get false, that means your solutions are in region 1 and region 3. So to write this in interval notation, I would say negative infinity to negative 5, or 5 to positive infinity. To write it in inequality notation, x is less than negative 5, or x is greater than 5. And that concludes today's lesson, solving quadratic inequalities.